Alright, we are continuing with our big idea of understanding operations, adding, subtracting, multiplying, dividing. Helps us to solve problems in the real world. Today our concept is to demonstrate an understanding of estimating when multiplying whole numbers. And this shouldn't be too difficult because we did do estimating with adding and subtracting just a short while ago, and much of the same is applied. Alright, Unit 3. Lesson 4. Reminder, there are no calculators for this unit. At this point, you may start to use a multiplication chart if you need it. But no calculators, only a multiplication chart. Sometimes we don't need an exact answer to solve a problem. Sometimes we just need an estimate. If we don't need the exact answer, it is called an estimate, and an estimate is a close answer. Okay, so for example, we raised $500. For sure we have enough money to buy 12 sweatshirts for the team. How do the students know they have enough money? It's $35 per sweatshirt. So to estimate that, we could say, okay, well, 35 is pretty close to 30. Oops, sorry. To 30. We need 12 sweatshirts, so let's go times 10, which is 300. Say we had 2 more sweatshirts, right, because we have 12 of them at $30 each. That's 60. So it's approximately $360, well below the $500 that they've raised. And notice this is an underestimate, so we would want it to be quite a bit below. We could do an overestimate, and we could say that the cost of the sweatshirts, instead of 35, this time we're going to make them 40. 40 times 10 is 400, plus 2 more, because we only have 2 here, at $40 each, that's 80. So even as an overestimate, the most we would have to have is 480. So we know we've got lots of money for that. Alright, so we know there are different ways to estimate. We could use compatible numbers. Compatible numbers are numbers that are close to the actual numbers and are easy to work with. They're usually multiples of 10 or 100, so usually they end in zeros. So for example, here we have another question, another problem. We have a bus that can seat 48 students. How many students can travel on 8 buses? So that would be 48 times 8, 48 groups of 8, because there are 8 people in 8 buses and 48 people in each bus. So with compatible numbers, I would probably round the 48 up to 50, and the 8, I don't necessarily have to round it up. I could, but annexing 0, this is quite easy. 5 times 8 is 40. I took off 1 0, so I'm going to add 1 more, so 400. When you're multiplying, it's often good just to change one of the factors if possible, just so that your number is closer to the actual. Alright, we could use compatible numbers and compensation. Here we have another problem. We have large jugs, one large jug, that fills 38 glasses. So 38 glasses in one jug. And we have 52 jugs. There are 52 jugs. So 38 groups of 52. 52 groups of 38 really, because we have 52 jugs and each jug is 38 glasses. So when it's 2-digit numbers, you do want to change both factors. It just makes it too difficult to do it mentally if you haven't changed both factors. So we're going to change 38 to 40. That's a compatible number. And that one went up. So if we were using compensation, this next one would have to come down, which is logical. 52 would come down to 50. And now we can use our annexing 0. 4 times 5 is 20. I took off 2 zeros, so I have to put 2 zeros back on. So 2,000 would be my answer. 2,000 glasses of juice is what we have possible. All right, let's take a look at our next problem. Here we're estimating 48 into 8. Think of multiples of 10 and 100. Choose one or both factors. And in this case, because 8 is just a one-digit number, I probably wouldn't change it, just so that my answer isn't changed that much. But you could. It wouldn't be a huge deal. So 48 is close to 50. I'm going to make it 50. 8 I'm going to leave at 8. 5 times 8 is 40. I took off 1 0, so I'm adding 1 0 back on, is 400. Or, if I change them both, 48 I'm going to make into 50, 8 I'm going to make into 10, which then makes it 5 times 1 is 5, and I have to add my 2 zeros back on, 500. So it's not a huge difference, but it is 100 difference, so it's somewhat larger. Again, we know we have rounded at least one number up, or in this case, both numbers up. So we know that this is an overestimate for both of these. They're both larger than the actual number will be. Whenever you make a factor a greater number, the estimate is going to be greater. So it will be an overestimate. Whenever we're making those numbers bigger, it'll be an overestimate. If we're making those numbers smaller, it's an underestimate. All right, during summer vacation, Julia delivers 215 flyers each day, and she delivers for 1 week. We know 1 week is 7 days. That's our background knowledge that we need to recall. So 215 times 7, and I'm going to go with benchmarks, I guess, and I'm going to round to the 2. So 2, look at the 1, tells us the 2 stays the same, so 200, fill the rest with zeros, times 7. I'm only going to change one of them because I don't really need to change the other one, and now I can get closer. So 2 times 7 is 14. How many zeros did I take off? Well, I took off 2, so I have to add 2 back on. 1,400. So approximately 1,400 flyers is what she's delivered. And that was using benchmarks. So if we've used compensation, we've used compatible numbers, we've used benchmarks. All of the same strategies that we use for adding and subtracting. We could also use front-end rounding, where the front digit becomes the factor. So there are 6 performances of the school play. There are about 240 people at each performance. So 6 groups of 240, which means we're multiplying front-end rounding. 6 I'd leave as 6. 240 would become 200. And again, annexing 0. 6 times 2 is 12. I took off 2 zeros. I have to add 2 zeros back on. 1,200 people came to the play as an estimate. Of course, remember, with front-end rounding, both numbers, or at least one number, is going down and the other number staying the same. So it is an underestimate. All right, so let's review our estimation strategies. And remember, an estimation is a close answer, and an estimation is not doing the actual answer and rounding your final answer after you have done the actual. That is not an estimation, that is a rounding. So make sure that your estimation is where you've changed both of your factors, or your dividend and your divisor, but it cannot be just the answer that you've changed. All right, so we have front-end rounding. We always take the first number and change the rest to 0, so we cannot be changing those other than what's already there. Has to be 4, has to be 6. Remember, it can also be 450 plus 630, so we've still kept the same front numbers, but in this case we're keeping 2 instead of just 1, which would make it a closer estimate. Even though it's front end, it would still be closer if we're using more of the actual digits and changing less of them. Next we have compensation. 1 goes up and 1 goes down, and usually we look at that logically. Okay, 459 is going to round up. I'm going to make that 500. 632 is going to round down and make that 600. So it's a bit of a combination with benchmarks. Usually this one gets you to a fairly close estimate. It's a good strategy to use. Next, we have compatible numbers, changing the numbers to ones that are easy to work with. Now this one can be quite different depending on what's easy for you and what's easy for the other person, so you have to watch it a little bit. But 459, 450 is pretty close, it's easy to work with. 632, 650 is pretty close, it's easy to work with. Often it should be a number that ends in 0 again, is a multiple of 10 or 100. Last strategy, benchmarks, rounding to the nearest place value, and usually you're given the place value. Might be the tens place, might be the hundreds place, depending on how large your number is. In this case, we have 459 and 632, and we've changed them to the tens place. The 5 looks at the 9. Remember our rounding rule. If it's 4 or less, ignore. If it's 5 or more, add one more. So we would have to add one more. The 5 would become 6. The numbers in front stay the same. And the numbers after become zeros. Same thing here. My 3 looks at my 2. My 2 tells me it's 4 or less, so I just ignore. So the 3 stays the same. The 6 stays the same. And the 2 becomes 0. Now I've shown you these with adding and subtracting. But the same would apply for multiplication. The only thing that I would suggest is that if one of the factors is a 1-digit number, I would probably just leave it alone. If it is a 2-digit number, I would change both factors. All right, now you get to do some practice. All right, let's determine what strategy we're going to use for each. So let's use compensation. Let's use front end for this one. Let's use benchmarks for this one, and because our largest digit is the tens place, we're going to make it to the tens place. So benchmarks to the tens. And then the last one would be compatible numbers, so easy to work with numbers. All right, press pause and try each of those now. All right, let's take a look. And again, remember when we're estimating, your answer might be slightly different depending on what numbers you changed it into, but it should be fairly close to what we've come up with. All right, so we had compensation for the first one, so 1 up, 1 down. Now, really, it's 64 times 8, and that's a 1-digit factor, so I'm not going to change that one. I'm going to leave it the same. And 64, I'm going to bring it down to 60. 6 times 8 is 48. I took off 1 0, so I'm adding that 0 back on. So annexing 0, really important when we're estimating. B was front end, so that means the front digit stays the same. The other one changes to a 0, and because it's 2, it just stays 2. There is only 1 digit. It is the front digit. Now, 7 times 2 is 14. I took off 1 0, so I'm adding that 0 back on. 140. And the last one was compatible numbers. Easy to work with numbers. And 70 times 25. 70 is already pretty easy. I'm going to leave it. 25, I'm going to make 30 because I need an overestimate. Perhaps we're working with money and I want to make sure that I have enough. So 7 times 3 is 21. Took off 2 zeros. I'm putting those 2 zeros back on. 2,100. Remember when you are working that you are remembering to tell what strategy you used. Remember, if it's an explanation, that you are using words. Remember to show your work. Now your work should look similar to what we just did here. Okay, so this is the only work that I need to see. I don't need to see a whole lot more than that. I don't need to see the long multiplication, but I do need to see this work. I need to see what numbers you changed them into to see if you've done the correct strategy. All right, concept practice. Estimating with whole numbers. You are working in your textbook, page 86 and 87, numbers 1, 2, and 3. As I've said, remember to show your work and to use words to explain. You can have an example, but you need to have sentences and words in an explanation. And of course, as you're working, remember to ask questions if you are unclear.